I'm Shay. I'm a first year in Sam Stevenson's group, and I will be talking about how El Nino is changing due to climate change. So first, the first question we have is, what is El Niño-Southern Oscillation? It's a climate phenomenon that occurs every 2 to 7 years. And it's characterized by a warm phase, which is has warm sea surface temperature anomalies, which is seen in this red band right here. And then a cold phase, which has cold sea surface temperature anomalies, which is depicted in this purple band. And the warm phase is El Nino, the cold phase is La Nina. And these sea surface temperature anomalies have impacts that reach all over the world. So the effects of El Nino Southern Oscillation are not just confined to the equatorial Pacific. And one of these impacts that we see all over the world are, or not all over the world. One of the impacts that we see is severe storms on the US West Coast, such as the rainstorms that we saw last month that canceled school. So these storms, they already cause severe flooding, so they could be, and they could be exacerbated under climate change if future El Nino events are stronger. So we want to know, how does ENSO change due to climate change so we can understand these impacts? And to assess this question, address this question, we use climate models to evaluate future changes to ENSO. They're our best tools that we have for projecting the future. Models approximate the physics of the Earth system and also include human influences to give a large-scale picture of the climate, which is pretty good, but not always perfect. There's a lot of models that exist with different physics, and they get different answers for what happens to future ENSO. And the model that I'll be using or that I'm using in this research is the Energy Exascale or System Model, or E3SM, from the US Department of Energy. And so we find in this model thus far that El Nino gets stronger in the future. So that's what this red band shows, that future sea surface temperature anomalies get larger relative to what they are now. So that means that El Nino would be more extreme. And so that means that there could be more extreme impacts. So the next question in future work, we want to know why El Nino is strengthening under climate change. So we want to identify what physical processes contribute to a strengthened El Nino. And particularly, I want to focus on small-scale ocean processes like mixing. And we want to understand this because if we understand the mechanisms behind changes in El Nino, we can better predict future extreme events, and that helps people better prepare for extremes.